Hi everyone, in today's lesson we are going to talk about when we should use pressure, concentration or amount in the ice table. So I think one of the major concerns that students have is this area here where they don't know whether they should choose amount, pressure or concentration. So today we are going to discuss about that. So if you look at our typical ice table, alright, so let's say I have A that which is in equilibrium with 2B. So what I will get is, let's say at the start I have 5 and it will start breaking apart, so I will say there will be minus x here and plus 2x. How do I know that it's 2? Is because the coefficient here is 2 and the coefficient here is 1. So I get 5 minus x and 2x over here. So if you look at this, you'll notice that the reason why this is 1 is to 2 is because we are looking at the mole ratio. So in fact, using the amount is actually the most accurate answer. So in that case, when can we use pressure and concentration? So sometimes we use pressure and concentration straight away, all right, and we usually use that to as a proxy for amount, right? So how do we actually do that? So we have to look at them one by one. So let's start with the easier one, which is concentration. So concentration is equal to amount over volume. All right, so for concentration to be proportional to amount such that the mole ratio is the same as concentration ratio, okay, volume needs to be constant. All right, so as long as the system has constant volume, then your concentration and the amount will be proportional to one another, so the concentration ratio will be the same as the mole ratio. So in that case, when your container is of a fixed size, or rather when you don't mix two solutions together, okay, then you can use concentration instead. But if the volume of the total solution changes, then you will have to use amount. For the second part, let's say we talk about pressure, we use our PV is equal to nRT. You'll get P is equal to N times RT over V. So what this means is that for P to be proportional to N, T and V have to be constants. So in this case, if the size of your container increases, right, the volume will change. And so P is no longer proportional to N, so we cannot use pressure if the volume of the container changes or the temperature of the system changes. Right, so the only time you can write pressure or concentration here is when temperature and volume remains the same.